Our next lesson in geometry is called converse, inverse, and contrapositive. Let's go ahead and look at our goals for this lesson. Our goals are to identify the converse, inverse, and contrapositive of a conditional statement and determine if a statement is true or false. Okay. Let's look at our vocabulary words. A statement formed by interchanging the hypothesis and the conclusion is a conditional statement. And a conditional statement is a converse of a conditional. A new statement formed by negating both the hypothesis and the conclusion is an inverse of a conditional. And formed by exchanging the hypothesis and the conclusion and negating both of them is the contrapositive of a conditional. Alright. So go ahead and get your notes. Go ahead and skip a space and write today's date. And the name of this lesson is Converse. I think we'll just do one of them at a time. Let's do converse. Okay, last time we talked about conditional. I'm going to let you use this chart on your quiz. So go ahead and get another sheet of paper that's not in your notebook, because I'm not going to let you use your notebook during the quiz, but I will let you use this. Okay. I'm going to draw a chart. I guess it doesn't have to be too. And this is a truth table. I want to put this so you can see it. Okay. So I have P and Q. And there are four possibilities. P can be true and Q can be true. P can be true and Q can be false. Or P can be false and Q can be true. Or P can be false and Q can be false. Okay? So here we go. First thing we're going to talk about, well, I want to do this too. We talked about negation. Negation says not P, not Q. Okay? That means that if it's true, we change it to false. We just write the opposite. So if P is true here, so here it will be false. Q is true here, so here it will be false. P is true here, so here it will be false. Q is false here, so here it will be true. P is false here, so here it will be true. Q is true here, so here it'll be false. So negate means we just do the opposite. Those are both false, so over here those are both going to be true. And that's a horrible F, so I'm going to redo my F. Okay? We talked about conditional. Conditional says if P, then Q, or P implies Q. And we talked about this in the last lesson. But we said that, and we're going by this, not by the negate, we're going by this. Okay, this is our starting point, this over here. If P is true and Q is true, then our statement is true. If P is true and Q is false, our statement is false. If P is false, it doesn't matter what Q is. The statement is true. Okay? Alright. Today we're going to talk about, well, right now we're going to talk about converse. Converse is instead of if P then Q, we're going to say if Q then P. Okay? So this right, I'm going to put converse over here, and I'll tell you why later. Converse. But this says if Q, then P. So what we do is we switch them. Okay? And according to our converse, does it confuse you? Should I draw the lines? Will that help you? Probably should have drawn the lines first. My lines are not very straight, are they? Okay. This says if Q is true and P is true, then the converse is also true. The converse says that if Q is false and P is true, that the converse is true. If Q is true and P is false, then the converse is false. And if Q is false and P is false, the converse is true. So if you compare this with the conditional, the only difference is when they're not the same thing. Okay? On the conditional, if they're not the same, whatever Q is what the conditional is. On the converse, if they're not the same, whatever P is what the converse is. Okay? For example, if I said, if today is Monday, then tomorrow is Tuesday. Today is Monday, that's true. Then tomorrow is Tuesday. That's true. True to true, so my conditional is true. Now my converse, I have to turn them around. So if tomorrow is Tuesday, that's true. Then today is Monday. That's true. They're both true, so my converse is true as well. Okay? It's easier if you establish what P is and what Q is. For example, if I say, if 5 plus 5 is 20, so P is 5 plus 5 equals 20. Q is 3 plus 2 equals 5. So your statements usually have nothing to do with each other. They're just two different statements. Five plus 5 is 20. Is that true or false? Well, we know it's false. 3 plus 2 is 5. Is 3 plus 2 5? Yes, it is. That's true. So according to my conditional, if P is false and Q is true, my conditional is true. But my converse is going to be, if 3 plus 2 equals 5, then 5 plus 5 is 20. So my converse, on my converse, if P is false and Q is true, my converse is false. Okay? Alright. Now I think the thunder's trying to out-talk me. Okay, let's do another one. Okay, this says here's P and Q. P is always the first part of the statement, okay? If a point lies on a line, okay, so P is a point lies on a line. Q says the line contains the point. The line contains the point. Okay. Well, it says if a point lies on the line, so we're going to have to assume that the first part is true, then the line contains the point. Is that true? If a point lies on a line, does the line contain the point? Well, yes, it does. That's true. So on my conditional, if P is true and Q is true, my conditional is true. Okay, now let's do the converse. If a line contains the point, so we have to assume that the first one's true, then the point lies on the line. Is that true? Yes, it is. So that's also true, so my converse is going to be true as well. Okay? So this is how we do converse. Alright? Now the next one we're going to talk about is inverse. What do you think inverse means? Okay, in your notes, I want this chart in your notes as well. On your paper that you're using on your quiz or your test, you can only put the chart. You can't put anything else I'm going to write, okay? But an equivalent statement, and this just goes in your notes. This is not, you're not going to use this on your test, okay? Equivalent statements is if P then Q is true, so if the conditional is true, and if Q then P is true. So equivalent statements are if my conditional and my converse are both true, then they're equivalent statements. And you'll notice they're equivalent statements whenever P and Q are both true and whenever P and Q are both false. Okay? Alright. Now the next one we're going to talk about is inverse. Okay. Inverse. What do you think inverse would mean? Well, if you invert something, you do the opposite, right? We invert a fraction, we put the top on the bottom and the bottom on the top. That's inverting a fraction. Okay. What we're going to do here, I'm going to put inverse all the way over here. Inverse says we have to negate, look at the conditional right here, and negate them. Inverse means if not P, then not Q. Okay? So this says, now you'll look right here, we have negation right here. It's going to be easier for the inverse if I look at this chart than if I look at the conditional one, than if I look at the statements I started off with. So this says, according to my inverse chart, if not P and not Q, this is going to be a true statement. Inverse says if negate P is false and negate Q is true, this is going to be a true statement. It says if negate P is true and negate Q is false, this is going to be a false statement. And if negate P is true and negate Q is true, this is going to be a true statement. Okay, so if you'll look, you're going to see that my converse chart and my inverse chart are the same thing. That's why we put them together on the chart, so you could see they're exactly the same chart. Okay? Okay, so let's try some of these and see how we do. You should have those in your notes by now. Okay, this says, okay, this is my conditional, okay? The first thing we need to do is label P and label Q. P says, if 5 plus 5 is 20, P says 5 plus 5 is 20, okay? Then 3 plus 2 equals 5. Okay, well, let's look at it. Does 5 plus 5 equal 20? No. So P is false. Does 3 plus 2 equal 5? Yes, it does. So this is true. Okay. So the inverse is going to say if 5 plus 5 does not equal 20. Okay. If 5 plus 5, the inverse means that I have to say the opposite. If the conditional says 5 plus 5 equals 20, then the negate is going to say 5 plus 5 does not equal 20. And that's true. 5 plus 5 does not equal 20. And this is going to say, instead of 3 plus 2 equals 5, this is going to say 3 plus 2 does not equal 5 because it's the negate. We have to say the opposite. Is that true? 3 plus 2 does not equal 5. No, that's false. Okay? So let's see. Negate says if we have a true and a false, my statement is false. Okay? True and false, my statement is false. Alright, so let's try another one. This says, okay, my conditional says, here's P, here's Q. Okay. My conditional says if today is Friday, so P says today is Friday. Then yesterday was Thursday. So Q says yesterday was Thursday. Okay. Now, I want you to finish this conditional. Tell me if this is a true or false statement. And stop the tape, do that, and then compare it with mine. Alright, let's look at it. Because if today is Friday, and we're going to have to assume that that's true. This says yesterday was Thursday. Well, if today's Friday, then yesterday is Thursday. That's true. Okay? Now my negate, almost didn't leave room for this, did I? Negate, remember, I have to say the opposite. Since the conditional is today is Friday, negate is going to say today is not Friday. So that's going to be false. And this is going to say, if today is not Friday, yesterday was Thursday. I have to say the opposite. Yesterday was not Thursday. So that's going to be false. So I look at my chart, negation. I have two false, false, false. So my inverse is true. So you should have come up with true. Did you get that one okay? Alright, let's try another one. I just want to make sure you're understanding this. And I know I'm throwing a lot at you today. Let's do one more. Okay, we'll say, here's P, here's Q. If 3 is greater than 5, so P is 3 is greater than 5, then 3 does not equal 4. 3 does not equal 4. Okay, I want you to do the inverse for this one. Stop the tape, figure it out, and then compare it with mine. Okay, well, let's look at it. Is 3 greater than 5? No, it's not. That's false. 3 does not equal 4. Is that true or false? Oh, that's true. Now we have to do the negate, the opposite. Since it says 3 is greater than 5, negate is going to be 3 is less than or equal to 5, right? Is 3 less than or equal to 5? Yes, it is. That's true. If this says 3 does not equal 4, so the negate is going to say 3 equals 4. Does 3 equal 4? No, that's a false statement. So let's look at my negate. I have true, then false, true, false. So my inverse, you should have come up with false. Okay? All right. Now in your notes, okay, I want this in your notes. Not on your chart, but I want this in your notes. A conditional and its inverse are different statements. The examples show that an inverse of a true conditional may be true, but it may be false. The conditional and its inverse are not equivalent statements. Logicians have used the term if and only if when a conditional statement and its converse are true. Okay? So we just got through saying that an equivalent statement is if the conditional statement and its converse are true. So the last thing you wrote down was equivalent statements. So underneath that I want you to write if and only if. Okay. This is something we use with equivalent statements. Another thing we say is necessary and sufficient. Okay, so if and only if and necessary and sufficient are the same thing. Don't worry about it. We'll talk about it later, but I want it in your notes. You just right underneath where you put equivalent statements, or put this in your notes and draw a line to it so you know what we're talking about. We use these to signify equivalent statements. In fact, I'll do this. Equivalent statements. So whenever you see those phrases, remember we're talking about equivalent statements. We're talking about times when the conditional and converse are true, which is when they're both true or when they're both false. Okay? Okay, so we talked about negation, conditional, converse, and inverse. Now we're going to talk about contrapositive. Okay? All right. I keep erasing this word because I want you just to write the word underneath it wherever you're at on your notes. Okay, on your chart, I'm going to put contrapositive right here. Contra. And I'm going to put a plus sign for positive. Okay, so this is contrapositive. When if P then Q is a conditional, A new conditional can be formed by interchanging the hypothesis and the conclusion and negating both of them. So inverse, we negated them. Now we're not only going to negate them, we're going to switch them. So this is going to say, if not Q, then not P. Okay, this is called the contrapositive of the conditional. And according to my chart, if P and Q are both true, then the contrapositive is true. If P is true and Q is false, the contrapositive is false. If P is false and Q is true, the contrapositive is true. And if they're both false, the contrapositive is true. And you'll notice by looking at my chart that my conditional and my contrapositive are both the same charts. Okay? So we arranged it on the chart in such a way where visually it'll help you understand this more. It'll help you grasp it quicker. Here we go. This is what we have. Okay. First thing I have to do is label P and Q. If today is Sunday, tomorrow is Monday. Okay. So this says today is Sunday, because P is always first. Q says tomorrow is Monday. Tomorrow is Monday. Okay. Is today Sunday? Well, we're going to have to assume it is. It says if today is Sunday, so today's Sunday. Is tomorrow Monday? Yes, it is. Okay. Contrapositive says, now remember, we have to switch them and negate them. Okay? So switch them means we're just going to read this one first and then that one, but we're going to have to negate them. Okay? So instead of tomorrow is Monday, tomorrow is not Monday. Today is not Sunday. So this says, if tomorrow is not Monday, we're going to have to say that's true, then today is not Sunday. That's true. According to my contrapositive, if they're both true, then my statement is true. Okay? Let's try another one. This time I want you to try one just to make sure you're understanding it. Okay? Here we go. P and Q. Okay, I want to see if you can do this. Here we go. Conditional. If a triangle has a right angle, then it is a right triangle. If a triangle has a right angle, then it is a right triangle. You can abbreviate that any way you want. If a triangle has a right angle, then it is a right triangle. Now I want you to find the contrapositive for me. Stop the tape and do it, and then compare it with mine. Alright, let's see how we did. We said a triangle is a right angle, so a triangle has a right angle. We said then it is a right triangle. Okay? Okay. Does the triangle have a right angle? Yes, it does. That's true. So if a triangle has a right angle, is it a right triangle? Yes, it is. That's true. Okay, now we have to do the contrapositive. So instead of has, we're going to say doesn't have. And instead of it is a right triangle, we're going to say it isn't a right triangle. Okay, so here we go. So if if it doesn't have a right triangle, that's true, then it's not, okay, if it's not a right triangle, then it doesn't have a right angle. Is that true? Yes, it is. So we have true, true. Contrapositive says it's going to be a true statement. How far did you get? Did you get that? Alright. So looking at the chart one more time, we notice that the conditional and the contrapositive charts are exactly the same. And we notice that the converse and the inverse charts are exactly the same. This reveals that a conditional and its contrapositive are equivalent statements. And it reveals that the converse and the inverse are equivalent statements. Okay? Now, in your notes, I want you to put, right where you are in your notes, logical equivalence is when two statements have the same truth tables. Truth tables. Okay, we've already done a lot of examples together. We'll do one more and then I'll let you do your lesson. Okay? P says 10 is greater than 7. Q says 10 is greater than 5. Okay, now I want you to determine the conditional for me. Okay, let's see how we did. Is 10 greater than 7? Yes, it is. Is 10 greater than 5? Yes, it is. So on my conditional, if I have two true statements, my conditional is true. So number 1, you should have come up with true. Okay? Let's look at number 3. Number 3, I have the same problem, but I want you to come up with, number 3 says, if not P, then Q. Okay, let's see how we did. Okay. If not P, if 10 is not greater than 7, that would be false, right? Then Q. Q is true. What would that be? If false, then true. So this is still a true statement. Okay? Alright. And I know that's not one that was on our chart. Okay, I want you to go through, make sure this chart is on your note for your test, but make sure it's also in your notes. Okay? If you write this chart on a separate sheet of paper, I'll let you use it on your quiz or your test. But I'm not going to let you if it's in your notes. Okay? So make sure it's in both places. Alright? Go ahead and study the lesson and go ahead and finish answering the questions.